The experience of latest conflicts has shown a significantly increased role of unmanned aerial vehicles. They conduct reconnaissance, issue artillery targeting, and can hit targets themselves. Kamikaze drones, which have proven themselves quite effectively in a series of recent conflicts, have become widespread. Relatively cheap and easy to manufacture commercial drones are almost massively used. At the same time, the fight against them is not an easy task, primarily because of their small size and low visibility. Western military-industrial companies are developing various technical solutions to counter such threats. Anti-drone systems as a whole can be divided into two components: information support and executive. Information support subsystems use radar, optical detection, and signal intelligence equipment. Each of these tools has both advantages and disadvantages. The radar, for example, can be used in all weather conditions, day and night, but it is very difficult to identify the target. It is difficult to distinguish a drone from a bird. Optics make it easy to identify targets, but their detection is difficult due to a rather narrow viewing angle, short range, and also depends on weather conditions and time of day. Signal intelligence equipment detects the control channel of the drone, but it is useless if the drone operates in radio silence mode and performs a flight along a pre-planned route using a satellite navigation system. Therefore, in the anti-drone technology, as a rule, the above-mentioned detection tools are used comprehensively. Executive subsystems are divided into two large groups of means: kinetic and non-kinetic. Kinetic means are, as a rule, small arms and cannon weapons and the like, and non-kinetic ones include laser, radio frequency weapons, and jammers of control and navigation channels of drones. One of the representatives of the electronic countermeasure systems for drones is the British system ODDS, which includes a detection radar, an optical survey and search system, and jammer. The radar is based on a phased array antenna. It uses continuous frequency modulated signals in the frequency range of approximately 10 to 14 GHz and fully digital signal processing. The radar allows you to detect small-sized drones in a plastic case, even if they fly very low above the ground or near buildings. The maximum detection range of miniature drones, according to various sources, is from 4 to 8 kilometers. The speeds of detected targets range from 0 to 400 kilometers per hour. The optical system consists of a high-resolution day camera and a thermal imager. According to the information from the radar, the system identifies the aerial target and accompanies it. High-resolution and digital image processing provide a range of up to 4 kilometers. The executive subsystem of the complex is a jammer of control and navigation channels. The operating frequency range is from 400 MHz to 6 GHz. Directional antennas with a directional pattern of about 20 degrees are used, which simultaneously provides a high gain and reduces the likelihood of unintentional impact on their electronic means. The control is automatic, but it can also be with the participation of an operator. The system is modular and can be placed at various facilities, including a transport base. Another example of electronic countermeasures to drones is the drone dome system of the Israeli company Rafael. The information subsystem, in addition to the radar and optical search and survey system, includes signal intelligence equipment designed to detect and identify drone control signals, as well as to select the most optimal interference. Effect: the jammer of control and navigation channels carries out the operation of drones. The characteristics of the drone dome system are similar to the British system ODDS. Currently, a large number of such systems have been created in different countries. They certainly have their own characteristics, strengths, and weaknesses. Some have better optics or a radar, others have equipment for signal intelligence and jammer. But the general trend is the integration of these devices to solve the common task of countering UAVs. Electronic rifles are another means of electronic counteraction to small-sized drones. These are relatively simple devices that provide jamming of control and navigation channels of drones. To date, there are a huge number of varieties of such tools in the world. At the same time, their common features are the need for visual detection of the drone by the operator and short exposure ranges. As a rule, it is hundreds of meters. Laser weapons are considered as one of the directions of development of non-kinetic means of drone destruction. One example is the American HEL-MD laser weapon system being developed by Lockheed Martin. According to some statements, it was possible to achieve a laser radiation power of 300 kilowatts. The range of heat power destruction of the target is presumably 3 to 5 kilometers. The German system of laser weapons for the fight against drones is being created by the Rheinmetall company. Currently, the prototype images are being tested and hit targets at ranges of about a kilometer. To expand the capabilities of the National Missile Defense System, samples of iron beam laser weapons are being tested in Israel. The laser power, according to various sources, is currently tens of 1 kilowatt, but this value is planned to be increased to 100 kilowatts. These complexes are still at the level of experimental samples. Another type of non-kinetic impact on drones is radio frequency weapons. One example is the American Thor system, which strikes the electronics of drones with powerful directional pulsed radio emission. When exposed to the electronics of drones, including the control unit, digital equipment temporarily fails, as a result of which the drones lose control and fall. The strength of such a system is the ability to instantly hit entire groups of drones caught in the beam of the system. Similar weapons are announced by the European military industrial company Leonardo. The German company Rheinmetall has created the Mantis short-range anti-aircraft artillery system designed to protect important objects from low-flying aerial targets, including drones. The Mantis battery includes a command post, 2 fire control stations, including a radar and an optoelectric guidance system, and up to 8 anti-aircraft guns with a caliber of 35 mm. The system can operate 24 hours a day in fully automatic mode without operator involvement. Ammunition fuses are automatically programmed to detonate, depending on the parameters of the movement of the air target, so that the field of fragments hits the targets as efficiently as possible. The reaction time of the system from the detection of an aerial target to its firing is about 4 seconds. In the development of the Mantis, the Skynex system has been developed in which each module is a fully functional unit with the functions of detecting, tracking targets and defeating them. The system can be both stationary and mobile on a wheeled transport base. In the Turkish Shaheen system, a 40mm Shaheen automatic grenade launcher is used to destroy drones, and its range does not exceed 700 meters. A rather exotic sample of kinetic impact is presented by the American company Anduril. The information subsystem includes a detection radar and an optical identification and tracking system. Everything seems to be standard here. And as for the executive subsystem, interceptor drones are used here, which have increased maneuverability with a significant mass compared to the object of interception. Interception is carried out by a direct hit. It seems that such means of defeating drones may currently be more effective than non-kinetic ones. After all, the well-known opposition of the projectile and armor works here. For example, jamming systems are constantly being improved in the course of the development of electronic defense methods, such as software frequency tuning, the use of multiple control channels, the expansion of the frequency range, and others. Systems of radio frequency and laser weapons are large in size, rather low mobility. And they are still at the experimental sample stage. The probability of heat power laser damage is greatly reduced in bad weather conditions, as well as if the surface of the target is, say, mirrored. Nevertheless, in the near future, a number of companies are considering the integrated use of weapons of destruction, fire and electronic, and the choice of counteraction is likely to be based on expediency. Subscribe to the channel, put likes, write comments. See you soon.